Hello everyone, good morning to all of you. Good morning, Prudhvi. I hope my voice is audible and you can see the slides properly. I'll also open the chats here. Let me. All right, so it has started. Let us begin. So today in this class, we are going to study carbon and its compound. Florence, good morning. Madhu, good morning. Good morning, everybody. So let us begin the study of carbon and its compound. Okay. So please note there are three parts. One, today we are going to study carbon and its compound. Along with this chapter, you also have to study chemistry in everyday life. And then there is coal, petroleum and flames. Okay. So all these three chapters will help you with one another, beginning with the first one, that is carbon and its compounds. Okay. So similarly, when we study periodic table, then there is metals and non-metals, and then there is acid, base and salt. So those three chapters also you should, always take care that you are understanding all the three in the same go. So here we are going to start with carbon and its compound. So let us begin the journey where one single carbon can also exist, and then this carbon can form so many compounds. Okay, and so many compounds can be used. For example, if you say what is coal, that is also carbon. If you say what is diamond, that is also carbon. Then if you say that, all right, that we understand, but what about the human body composition? So there also, in the living beings also, we find carbon. So there is this vast number of compounds that carbon can form because of its properties, and we will see what are those. All right. So from food to clothes, medicines, books, everything that we are using, all of these contains carbon. All the living beings, if we consider all the living beings, all the living structure, that contains carbon. That is why you must have heard that if we have to do carbon dating, have you heard about carbon dating? So in case of the living ones, we can do once, whenever if there was a time when they were alive and now they're dead, so how long it has been, so we can find out by carbon dating, right? Or even if something is old, how old it is, to find out, we can use the carbon dating. Okay. Now the earth's crust, we know that, in if we consider about which is the most abundant material on the earth's crust, then our answer is oxygen. Oxygen is the most abundant material on the earth's crust. But what about carbon? How much carbon is there? There is only 0.02% carbon, that too in the form of, say, minerals, in the form of carbonates, in the form of hydrogen carbonates, coal, petroleum, etc. So I told you there is a separate chapter also for coal and petroleum, where we will also study how combustion of carbon happens. So that we will study in that chapter. Okay. Good morning. Next is the atmosphere. The atmosphere has 0.03% of carbon dioxide. So in the atmosphere, they ask you which is the most abundant gas. Then you know that, okay, in the atmosphere, we have only 0.03%. Sometimes in the options, you can also find 0.04. So that is also fine. Okay, so that is the atmosphere and its constitute gases. What are the components in the atmosphere? All right. Now, so we understood that basically everything has carbon, that we understood. Okay, now coming to the bondings in the carbon. What kind of bonding carbon forms? Now, when we are studying the periodic table, then at that time we understood that just like human beings, for human beings, okay, stable, you say that, okay, you want a house, you want the food and you want the clothing, right? Similarly, for this say periodic table elements, what they want to 8 like that, they also want to be stable in and want to achieve the noble gas structure or the noble element structure, the group 18 in the periodic table. But if you will look at carbon, then hydrogen, helium, lithium, beryllium, boron, carbon. How much? Only 6. Now, if you have to structure this, then it is 2 and 4, right? So the outermost shell will have this 4 electrons. But we also study during the understanding of periodic table that if it is less than 4, okay, if it is, okay, 2 is here, next, if it is say less than 4, okay, you want to achieve how much? You want to achieve 8. So if it is less than 4, if it is 1, if it is 2, if it is 3, then it will be easier to give this away. Give this away, giver will get the positive, right? And if it is more than 4, then if it is say 5, that means 6, 7, 8, you require 3 more. You can accept it, and acceptor will get the negative. And if it is say 6, then you just need 2 more. If it is 7, then you just need 1 more. Just before this one, you see fluorine, chlorine, bromine, all these, they will have the similar pattern. So this we will study in the periodic table also. Now carbon being 4, it is indecisive. What to do? It is not easy to give away also. It is not easy to borrow also. It is stuck in between. So what carbon will do? It will not form ionic bonds. It will not form the ionic bonds. It will form the covalent bond. It will form the covalent bond. Now what is this covalent bond? These are the bonds which are formed by sharing of electron pair. Now it will decide that, okay, since it's stuck in between, so let us do the sharing. So carbon will do the sharing of the electron pair and it will form the covalent bond. That is why most carbon compounds are poor conductors of electricity, because for conduction of electricity we know that there is the requirement of this ions. So ionic compounds are good conductors of electricity because they have those ions, but the covalent bond formers, this carbon, you will see that they are mostly poor conductors of electricity. The reason being that they do not have these ions to conduct the electricity. They are already forming the covalent bonds. Okay. The forces of attraction between the molecules are also not very strong. How do you identify this? See, one, because anyhow we are not doing the ionic bonds, we are in covalent bonds. And another, if you don't want to do this comparison and if you want to check directly, then also you can check that they have this low melting and boiling points. And what does this low melting and boiling point state? It states that, okay, that the forces of attraction between the molecules, it is not very strong. Okay. Now today itself, before just have a look at this uh, boiling point and melting point, then we have a question also regarding this. So today itself we are also going to do a PYQ, previous year question series, from this very topic, that is carbon and its compounds. Okay. So do not miss that. That will also be uploaded. Okay. After you complete this study, you can practice the questions from this particular topic. All right. So now coming to acetic acid. Acetic acid means, you see here the melting point is 290 Kelvin and the boiling point is 391 Kelvin. Similarly, chloroform also you can see 209, 334, ethanol 156, 351, and methane is 90 Kelvin for melting point and boiling point is 111. So these are some common melting point and boiling point. Do we need to remember all of this? No, not required. But at least this basic is required because it is given in the standard books. And also there was a question which was asked in the exam. Can you try to answer this? What is the boiling point of ethanol? What is the boiling point of ethanol? So, what will be the boiling point of ethanol? What you have the understanding is that if you remember this, Then here you have the ethanol in 351 Kelvin. Like that also you can say convert it, or have an understanding that these compounds that they are forming, which has OH in the end, the ethanol or the OL compounds, say whatever it is, right? You will see that they will have the lower end melting point and boiling point. If there is still the OOH, that is the say acetic acid or whatever it is, if they have the OOH compound, then it is in the higher end. If you just have an idea of this two, then also you can convert and you can respond. What is your answer? No answers yet? So do the calculation and let me know what is the correct answer in the comment box. Okay. Coming to the next question. That is a molecule. No, you have to do the conversion. You forgot to do the conversion. You have to convert it first, no? Okay, now coming to the hydrogen atom. See, now for the hydrogen atom, you know that it is just one, right? So one here and one for this one. Now what they will do for stability, again we know that this one first has to have two, so they will decide to do the sharing of these electrons, and these shared electrons will give this hydrogen also 2 and this hydrogen also 2, so both of them will form the molecule, that is the hydrogen molecule. And there will be this single bond between the two hydrogen atoms. So what bond is there between two hydrogen atom? There is the single bond. Now coming to the oxygen atom. If there are two oxygen atom, correct Florence. If there is the two oxygen atom, then in this case we see that hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. That means how much? 8. Now that means you have 2 and 6, right? Now it is easy that you can ask for 2, right? Or what you can do is, if there is one oxygen and another oxygen, and if they are forming a double bond between two oxygen bond, then they will simply form the oxygen molecule. So this double bond will ensure, you see here, that this one will also have the stability and this one will also have the stability, and thereby forming the O2. Coming to the structure of methane. What is methane? CH4. Now CH4 means one carbon is there and already it requires 4, right? Remember? So if you put one hydrogen here, hydrogen will also be, say, stable and carbon is also stable. They got what they want, right? Hydrogen wanted 1 and carbon wanted 4. So with 4, say, hydrogen, carbon has formed the CH4, that is for methane. And methane is widely used for fuel. Methane is used for fuel. In biogas you find methane. In compressed natural gas you find methane. In rice and paddy fields where there is water and where there is, say, where there is marshy lands, then some gas will be released, no? So that one will also be there and methane will be found. Now coming to the allotropes of carbon. Allotropes of carbon. Allotropes of carbon means the different forms in which they will exist. Now we all know that ideally when we are studying the periodic table, then there is a zigzag line which will separate the non-metals from the metals, right? And these non-metals they are generally not as hard as the metals. Metals property, we study that metals are hard, metals are malleable, metals are ductile, etc., right? But you see, diamond, though it is an allotrope of carbon, diamond is the hardest substance which naturally occurs. What does that mean? That this is an exception. So wherever you will find an exception like this, it becomes important for your exam purpose. So diamond, even for the cutting of the glass, a pen-like structure, if it is used, in the tip you can see that there is a diamond. So that is used for glass cutting as well. So diamond is the hardest substance which is known, and even if in the case of periodic table, you will see even though it is in the non-metal side, even though it is not in the metal side, but still it is the hardest substance. So it becomes exception, and in the question it can be asked. Then graphite is smooth and slippery. Graphite is the exception because we had studied just before a few minutes that carbon is forming the covalent bond. So one, it does not have that high melting and boiling point, and since it does not have the ions, it is not a good conductor of electricity, right? They are poor conductors of electricity. We studied that. But now you see that graphite is a good conductor of electricity. But if again, be it from the point of view of covalent bonds and ionic bonds, or be it from the point of view of periodic table, carbon and its compound should not be good conductor of electricity. They should be poor conductors of electricity, right? But graphite is the exception. And again in exam, wherever these exceptions are coming, they are important for your exam. Okay. So graphite is a good conductor of electricity, right? Okay, one more thing. You remember that in case of, even if in the future classes also, if you will study, then you will study that, okay, that some non-metals, they are say they can be cut with a knife also, like sodium and potassium. And most of the non-metals, they are not as hard as metals. So in that case, it is fine. Graphite is also smooth and slippery. Now, these diamonds can be synthesized by subjecting pure carbon to very high pressure and temperature. Now, it is a universal rule in geography also you will study, in life also it applies, that everybody tries to move from high pressure to low pressure. Everybody moves from high pressure to low pressure. But what if you are ready to undergo the high pressure and high temperature? So diamonds can be synthesized by subjecting the pure carbon to high pressure and high temperature. Okay. So pure carbon to high pressure and high temperature, what will happen? Diamonds can be synthesized. All right. Now, okay, you can also have a look at this. Okay, here also we have the, since this looked like this, we are talking about the Buckminster Fuller was an architect who has given the, or based on whose name the name Buckminster Fullerens came. Buckminster Fullerens, this is carbon C60, okay, C60, and it looks like this, geodomic is like a dome, or if you have seen the tents in the say ice cold region, if you will see the tents, or in some tourism area, now they have this dome structure tents. So based on that, they have given the name of geodesic dome, which was designed by the US architect Buckminster Fuller. Okay, and since the Fullerens, igloos are okay, like igloos only, but igloo will be made of compressed ice blocks. Okay, and these are tents only. They are made from some other material and not directly by the ice. But if you are using the term igloo, that means it has to be made of ice. So it is nothing, just because of the structure appearing like this, they have given the name of given the name that is dedicated to the person who designed this kind of domes, and that is your Buckminster Fullerens. Okay. Now, coming to the next point, that is the versatile nature of carbon. So a quick recap, we have studied the basics of carbon. Okay. Then we have studied a little bit about the structure and why, because of the formation of covalent bond, they will not be the good conductor of electricity, they will be the poor conductor of electricity. Then there are exceptions, like wherever the exceptions, there can be questions like diamond, though it should not be, though it is metal, they are in the non-metal category, so they should not be as hard as the metals, but diamond is a natural hardest material. And similarly, graphite is also an exception, because non-metals, that means not conductors of electricity, but graphite is a good conductor of electricity. Now let us come to the versatile nature of carbon. So we will study two things basically. One is the tetravalency, which before some time also we had seen that carbon means this one. It is difficult to decide whether to give away or whether to accept, because it is in between with 4, and that is why it will decide, okay, all right, let us form the covalent bond, right? So that is your tetravalency, and another is catenation. So carbon, they has the unique ability to form bonds with other atoms of carbon, giving rise to large molecules. So if one carbon is able to form bond with other carbon, that too they can form the single bond, they can form the double bond, they can form the triple bond. What does it mean? It means that this is the unique ability, and like this you can actually come up with chains, right? So they can form this large molecules. And now we can divide these compounds into two types, that is into the two different types of bonds, that is saturated carbons and unsaturated carbon compounds. Saturated carbon compounds are those compounds which will only have a single bond. So if we are writing that carbon has the single bond, that means we can say that they are saturated carbons. All right. And unsaturated compounds means if the carbon has the double bond or the triple bond. So double bond or the triple bond between the carbon compounds, that means they are unsaturated compounds. Okay. So if we are talking about any compound where the two carbon or two or more carbons will have the, say if another compound is also there, that one also have the single bond. So wherever this single bond comes, single saturated, end of story. You will never forget it. How? Because saturated means single, okay, and unsaturated means double or triple bonds. So just remember, single is for saturated. The carbon-carbon bond is very strong and hence stable. So though ideally about with the other compounds, okay, it can differ. It is not like ionic bond, but the carbon-carbon bond, it is very stable, okay. And that is why this gives us the large number of compounds with many carbon atoms linked to each other. Now, why this is formed? Formation of these strong bonds of carbon is because of its small size. How does it matters? Let us see. Again, when we are studying the periodic table, that time also we understand that if the nuclear distance is, say, less, carbon is just, say, just you have to adjust only 2 and 4, right? Only with the atomic number 6. No, we are understanding with respect to the how many catenation is the property where one carbon is forming the bond with another carbon. Tetravalency, it can be occupied by anybody. It can be occupied by hydrogen atom. This, let us remember as the example of tetravalency, because though there is no carbon bond here, but still you can see this. But if I am making like this, okay, if I am making, say, ethene, then here you will see that this carbon bond which is being formed, this one is what we are calling as catenation. All right. Now, one reason for the formation of strong bonds by the carbon is because of its small size. Small size means it is near, so this bond will also be stronger. Okay, this enables the nucleus to hold on the shared pair of electrons strongly. If it would have been a large atom, then you see that the tendency of losing the outermost shell electrons is more, right? So similarly here also, since it is a small atom, that is why it is less and there will be strong bond formation. All right. So all these carbon compounds which contain only carbon and hydrogen, they are called hydrocarbons. Hydrocarbons means what? Only carbon and hydrogen. So that is your hydrocarbons. And among these saturated hydrocarbons, see, if you say saturated, that means we had seen that single bond, that means alkanes. Okay, alkanes. And unsaturated means double bond or triple bond, that means alkenes or alkynes. Okay, so alkane, alkene, alkyne. Unsaturated hydrocarbons which contain one or more double bonds, they are called alkenes. And those with one or more triple bond are called alkynes. So when we say alkane, that means they are the unsaturated one, they have the single bond. When we say alkene, they have the double bond and they will be unsaturated, and alkynes means also unsaturated and triple bond. So before some time only we had studied S for saturated, S for single, done. Now just add the word alkanes here, alkanes, okay? And double bond means alkenes and triple bond means alkynes. All right. Now, how these will be used, you will see in many questions also, and we are moving ahead also. Now, if you will make the electron dot structure for ethane, okay? Now see, methane means one carbon, ethane means two carbon, propane means, now here it is ane, that means just before some time we have studied methane means what? In the there will be one carbon. Ethane means there will be two carbon, and since it is ANE, just here you see it is ANE, that means there is the single bond. That means it is saturated carbon, there is a single bond carbon, like that it will operate, right? Now see, that means here is 1, 2, 3 is left for becoming tetravalency. This one means catenation, right? Now there is 1, 2, 3 is left for tetravalency, and here also 1, 2, 3 for the tetravalency. So now what will happen? We'll just add the hydrogen atoms here. Now see, in this case, let me use the highlighter. Here, this one we are calling it as what? This one we are calling it as catenation, okay? And this bonds with the hydrogen and this 4 valency satisfied, this we are calling as tetravalency. So I think with this you are able to understand about this bond formation. Now if you will say ethene, then we have seen when it is ANE, it was single bond. When it is ENE, it means there is the double bond. Also we know methane means 1, ethane means 2, right? So it is ethene, that means 1, that point number 1, that there will be carbon-carbon double bond, right? Because it is ethene, and if double bond has formed already, so now if we will measure that, okay, for tetravalency, how much is left? 2 is gone, 1 more, 1 more. 2 is gone, 1 more, 1 more. And what to put here? We put hydrogen, 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 hydrogen. Okay, so this will be the structure for ethene. And ethene means what? Again, this is saturated, is single bond. S for saturated, S for single. And this is your unsaturated ethene, carbon-carbon double bond, that is your catenation. And this hydrogen and fulfillment of this tetravalency, that is your the tetravalency. All right. So if this is understood, then we are coming back to the OL components. Okay. If say in place of this one group can also be attached, it can be an, say in case of ethanol, it can be an OL group. Okay, it is liquid at room temperature. Boiling point, just before some time there was the question, if you remember, that the boiling point was 78 degrees Celsius and the freezing point is minus 114 degrees Celsius. Commonly called alcohol. Good solvent, used in medicines such as tinctures, iodine tincture, etc. Okay. Then cough syrups and many other tonics as well. That's why many cough syrup will give that sleepiness effect. If somebody will take a cough syrup, then there can be this sleepiness. That's why prescribed to have the cough syrup at the night time, because it can make a person feel drowsy. Okay. Ethanol is also soluble in water in all proportions. In any proportion, it is soluble in water. Now, since this has been focused on the standard books, it has been focused on NCERT. So it is important to remember that ethanol, that means the boiling point is very less. It is 78 degree Celsius. All right. And it is commonly known as what? Commonly known as alcohol. Now try to answer this question, everybody. Which of the following is a use of ethanol? Manish has given correct answer. Rohit and Dipti, correct answer. Now see, did you not notice the other points as well? So it is a good solvent. You can use it even if the nail paint is drying. There also you can use some nail paint remover, or you can use some, say, the ethanol as well. All this is nothing but ethanol only in different proportions. All these cleaners also, they have ethanol only in different proportions. Okay. The cough syrup, it is there. In tonics, it is there. As a medicine, it is used. For the purpose of solubility, it is used. If something is getting hardened, it can be mixed. As a tincture, it can be used. So it can be used in these purposes. Okay. So that is why, at least if you are sure that, okay, B and C, it can be used. That means how to tick one option after knowing that B and C, it can be used, right? So even if you're not sure about manufacturing of paints and you're sure that B and C is correct, that means you can tick that, okay, now I have to tick on all of these only. Coming to ethanoic acid group, okay, that is ethanoic acid. Now this is commonly called as acetic acid, and it belongs to which group is added here? The acid group. We have some diagrams also, we are coming to that. Okay, and these are called the carboxylic acid. These are called the carboxylic acid. Now 5 to 8% of the solution of acetic acid in water, if it is there, that is nothing but what we call as vinegar. This will come up in chemistry in everyday life also. So vinegar is used as a preservative for preserving the pickles, and the melting point of pure ethanoic acid is 290 Kelvin. Now since it is, say, very low, hence it often freezes during winter. You will see if you have sirka stored in your home somewhere, it will freeze just like coconut oil will freeze, no? So similarly, coconut oil will, say, it will solidify. In case of sirka, you will see that in winter it will freeze in the cold climates. This gave rise to its name, that is glacial acetic acid, because it is freezing. That is why ethanoic acid is only acetic acid. Now though in the, say, 5 to 8% solution of acetic acid in water diluted form is the vinegar, but in the exam you will directly get is acetic acid is what? You have to say vinegar. And since it will, say, freeze during the winters, it will also be called as glacial acetic acid. Okay, it will also be called as glacial acetic acid. So all the names are for ethanoic acid only. Okay, and if you see that the mineral acids like HCl, These are completely ionized, okay? But we know that carbon is not, it is not forming the ionic bonds. So carboxylic acids are also weak acids, okay? So carboxylic acids are also weak acids. Coming to the next one, that is esterification reaction. Esterification reactions. Now, what are these esters? Esters are most commonly formed by the reaction of acid and alcohol. Okay, by the reaction of acid and an alcohol. It will give some sweet smell. This is it can be like citrus fruit smell, or it can be fruity flavor, but it will give that esters, and these are sweet smelling substances. These are used in making perfumes and other flavoring agents. Okay. Now, if we are treating with hydroxide, say on treating them with sodium hydroxide, what will happen? Sodium hydroxide is an alkali. It is not acidic. It is what? Sodium hydroxide, NaOH. Now, sodium hydroxide means it is alkali. Then in that case, this ester, it was formed because of this acid plus alcohol, right? But now if it is treated with the alkali, then it will be converted back to alcohol and the sodium salt of the carboxylic acid. Okay, and this reaction is known as saponification reaction. This is used for making of the preparation of the soap. That is the saponification reaction for making of the soap. So what we have to remember, that esterification reaction means acid plus alcohol will give the ester, and these are sweet smelling. This has been repeatedly asked. Today we will do the question session also, no? That there also you will see these are sweet smelling. Okay, please attend that session also, everyone, so that you are able to retain whatever you are learning here. All right. Now this sweet means, okay, esterification has happened, and now if it is again treated with the alkali, that is if it is treated with a base, if it is treated with NaOH, sodium hydroxide, what it will give? It will give alkali and the sodium salt. Okay, it will be converted back into the alcohol and the sodium salt of carboxylic acid. And this reaction is nothing but the one which is used for the preparation of soap. Now, why we are not extending that vinegar and the soap into the details? Because here we want to complete till this portion, and there is another topic I showed you in the beginning only, probably tomorrow's class, that is chemistry in everyday life. Okay. Now coming to the IUPAC name and the common name. Okay. So there can be a question based on this also. You have to take care of it, and you have to prepare a chart based on what is what. Say many of the times they ask you that, okay, if there is an ant bite, that means what will be there? So there is the formic acid or methanoic acid or formic acid. Okay, so this is a very common question, and rest in when we are studying the acid, base and salts, there also we study this important ones. So for the time being, I'll just keep it limited and give you an idea of what comes in that acid base chapter. And there is the acetic acid, which is the ethanoic acid. For this class, I'll be taking up only these two, that is formic acid and acetic acid. Okay, formic acid being methanoic acid, and it is present in the ant bites, and acetic acid means ethanoic acid, it is present in vinegar. Don't try to do all the facts in one go. It keeps on the fact learnings also keeps on progressing as you progress in the classes ahead. Okay, now try to answer this question, everybody. What is the common name of ethanoic acid? What is the common name of ethanoic acid? Everybody try to answer this common name of ethanoic acid. Okay, so except one wrong answer, everybody else has given the correct answer. Prudvi, Aditya, Subi. Florence has changed the answer now. Manish, Nanda, Rohit. Okay, correct answer, everybody. Try the next question. What is formed when ethanol reacts with ethanoic acid? Okay, so this is the alcohol. So what they are saying is this ethanoic acid on warming in the presence of few drops of concentrated sulfuric acid. What will be formed? Ethanol, just before some time we had seen, reacts. What is formed when ethanol reacts with ethanoic acid on warming in the presence of few drops of concentrated sulfuric acid? Okay, very good. Now, whatever we have studied, let us just try to recall it with the help of some diagrams. Okay, see, I told you about the two properties. One is tetravalency, another is catenation. So tetravalency means what? That carbon has a valency of 4. All this we have understood. We are just quickly going through it. Okay. Carbon has a valency of 4, allowing it to form 4 strong covalent bonds with the other atoms. Okay. Now, if you take the catenation property, it is nothing but carbon forming this branches or this chains or this rings, various different forms. It can form the bonds. It can be like, okay, carbon, carbon, like this also it can form the long chain reactions. It can form the long chain structures. It can form structures like this. It can form the ring structures. So all these are possible. All these options carbon has. Okay. This is what we call as catenation. Okay. Now coming to the structure, how the electron dot structure can be used to show this, or we can also draw like this. Say if we are taking the alkanes, okay. Now in this case, you see that they will, in the case of butane, they will form the carbon ring structure. Can you see there is a cyclic structure here? So this cyclic structure is formed. Either you can represent this cyclic structure in the form of bond or in the form of electron dot structure. In none of the one-day examinations, they are asking about structures. We don't need that. What we need to understand here is that this carbon one structure, if this is so easy to represent multiple times, what do we actually mean by this tetravalency and what do we actually mean by this catenation? Catenation and tetravalency, how do we have already understood separately. It means that 4 bonds that this carbon will, it can also be the ring structure, it can also be the cyclic structure. So here you see this is your, if they are taking cyclopentane, okay, cyclopentane, then in this case 1 2 3 4 5, and this structure itself is a cyclic structure. So that is why we are calling it as cyclopentane, and it has the cyclic structure. And here you can see that bond is formed and carbon is, again, it is also doing the tetravalency and it is also forming the bond with other carbons in a cyclic manner. Okay. Now coming to the electron dot structure, this is a way of representing. It can be represented like this also. Now coming to saturated bonds, we have seen alkanes. That means carbon-carbon single bond is there, alkanes. Say for example, ethane. Alkenes, that means unsaturated. Alkynes also means unsaturated. Alkenes means carbon-carbon double bond, and say alkynes means carbon-carbon triple bond. For example, ethane, ethene, ethyne. Now coming to the rearrangement, there is a concept of isomerism. Okay, isomers are compounds that have the same molecular formula but different structural arrangement. Okay, So even with the same molecular formula also, say the isomers of pentane, if we are considering pentane's formula and the isomers, then it can have the N-pentane, which is the straight 5 carbon, say it will form the bond like this, or it can be isopentane. That isomerism is when it will have the same formula. Same formula means, say here it is C5H12. Okay, but the arrangement can be in the different forms. You see here 1, 2, 3, 4, 5. 5 carbons are there, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 hydrogens are there. But it can be arranged in N-pentane style. It can be arranged in 2-methyl butane style, or it can be chain of 4 carbons. It can be isopentane style, or it can be neopentane style. Okay, that is, it can be arranged in this form also. They can exist like this also, they can exist like this also, and they can exist in number 3. So they have different styles of how they exist, different styles of how they form the bonds. Okay, and this is known as isomerism. So in exam, what kind of questions they will ask? Do you need to remember these structures? No, you don't have to remember these structures. What you need to remember is, what is isomerism? So isomerism means they will have the same molecular formula, but different structural formula. This is your question which you have to remember. Number 1. Number 2, only for the one for which I am giving you the example, that is for pentane. Only for the isomer of pentane, remember that it can be in the form of N-pentane. If they ask you which of the following is an isomer of, say, pentane, then you have to tick from the options N-pentane, yes. If they're asking isopentane, yes. If they're asking neopentane, yes. If they're asking all of the above, yes, all of the above. So this is what you have to remember. Okay. Now coming to addition and substitution reaction. In case of the unsaturated hydrocarbons, we have seen S for saturated, S for alkanes, S for single, right? And unsaturated hydrocarbons means alkenes and alkynes. In case of addition reaction, the double or triple bond can break, allowing new atoms to be added directly. For example, if you see propene, if you say ethane, in this case, what happens? They can, even this double or the triple bonds, it can be broken as well, and they can have the addition, they can become the new molecules. In case of substitution reaction, one or more hydrogen atoms are replaced or substituted by another atom, as there are no double bonds to break. Double bonds, triple bond, okay, it can break, but here it cannot break, right? So what they will do here, it will be substituted. Say for example, in case of when we had methane, then we did it as, okay, C4 carbon hydrogen, then we did, okay, this is your methane. Now this is already single bond, this is already alkane, nothing is there to break. So we can replace this 1H with, say, chlorine, or whatever you want to replace it with, we can replace, and then we can form the new compound. So either they can, how their exam will, how the exam question will be formed, that in case of saturated hydrocarbons, okay, addition reaction or substitution reaction. So you have to remember, if they're asking in case of saturated hydrocarbons, there will be the substitution reaction, and in case of unsaturated hydrocarbons, there will be the addition reaction. Okay. Now there is one test, which is the bromine water test. Okay, you can read this by yourself. They are not asking much, say, questions from here, but just you have to remember that how do you distinguish between the say saturated and the unsaturated hydrocarbons. So you have to remember that yes, Saturated and unsaturated hydrocarbons can be recognized by which test? Answer, it can be recognized by the bromine water test. Okay, it can be determined by the bromine water test, where brown colored bromine water to each hydrocarbon samples is added and then it is shaken, and an addition reaction occurs, the bromine is consumed and its brown color disappears. Okay, so if it will disappear, that means what will happen? There will be the unsaturated hydrocarbons. Now coming to the power of combustion. That is, if you are using any, if you see any flame, for the blue flame, that means energy efficiency is there, there is oxygen supply and proper sufficient oxygen is provided and complete combustion is happening, there is no fuel loss as such or minimum fuel loss. But if you see that your vessel is getting darkened, if it is becoming blackish in color, if there is some soot, that means what is happening here? The sooty flame is there. There is unburned carbon particles. There is incomplete combustion, insufficient oxygen, and your fuel is also being wasted. I think from here we will be continuing in the class that is for fuels. Okay, and there itself, from combustion to fuels, we will do that. Okay, so for now on, just for this part, just remember that the application of complete combustion in sufficient oxygen, it is there in welding. Okay, so ethene is burned with pure oxygen and not air, and this gives the intense heat. So what is there? There is ethine. It is burned with oxygen, pure oxygen, to give this, say, welding. Okay, and then in case of incomplete combustion, whenever you are cooking in wood, for example, in that case what will happen? The vessel will turn more black because there is insufficient oxygen. And in gas, if you are using the, if you are cleaning the pores for time to time, then there will be sufficient oxygen and there will be the complete combustion. All right, so from here we will continue in the next class, which is about how they will say undergo combustion. In that class we will continue from here. All right, so that will be enough for our today's class. I will upload the question series by the end of the day. Okay, so please practice the questions as well after completing this chapter. All right, everyone. Okay, so I'm going to end this class here because there is another class as well. Is there anything else that you want to ask? Okay, thank you everyone. So coming back to the first point again, there are 3 chapters in this one. So the other 2 chapters we will continue from here. All right, thank you. Bye bye.